Hello and welcome back to my YouTube channel again. So in this video we're gonna learn about simple linear regression. So what is simple linear regression? What are some assumptions? Like we usually confuse between logistic regression and linear regression. So what exactly are those? So let's directly go to first some slides so that we can understand some of the basic understanding, and then we can start directly. So what basically is regression problems and what basically is classification problem? So regression is nothing but if we have to return some values, like if I have to predict the price of a house, so that kind of a problem will consider comes under regression. So if I have a classification problem, so it will mostly like I will fail the exam or I will pass the exam, like yes or no kind of thing. So it's the basic thing. The second is linear regression. The example here we are taking as like area and a price. So if we have some area and we have some price, we have x-axis in which we plotted all the area in square feet, and on the y-axis we have price in lakh. So you can see the data points here. Similarly, we have to decide which line will fit this curve, because in linear regression what we do usually here is we try to make a single line that fit all the points here, and which passes, fit is nothing but passes through all the most of the coordinate, so that we can predict if we have some certain area, so we can predict by using this model that what will be the price estimation there. So there will be a very huge question here. So how many line we can draw, and which one we should decide, like which one will be the best one? So the answer should be the minimum distance point is the best line you can make, and it is made by mathematical formula where you can take the distance and subtract it subtract them and square them. It's kind of Euclidean distance, if you know about it. So it's not exactly that, but it's sort of same. So and if you have to look at the equation of the line, so as you know that y equals to mx plus c is the equation of the line. So where the line passes, where it touch on the y-axis is called intercept, and the point on the y-axis, the line which touches the x-axis, it's called slope. So this is the slope, as you can see, and this x variable and y variable. So y we have to predict, so it's called independent variable, and x is the dependent variable. I hope that's clear. So let's start the coding part here. So I have created this Jupyter notebook sort of thing. So if you know about Jupyter notebook, you will definitely know about Jupyter lab too. So some of the assumptions are also there for linear regression. You can read them. I will put this notebook in like my GitHub repo. I can put the link down below. You can use that link. Some of them are like they should have linear relationship between them. There should not be no there should be no autocorrelation between them. It's mean like the independent and dependent variables should not be correlated, because if they are, we can't make up good prediction. And so independent variable and dependent variable should not be related, sort of that thing. So a lot of people confuse about logistic regression and linear regression. So as the name suggests, logistic regression, but if you go in a bit deep here, the logistic regression is a classification type. So you can see sort of here. So if I have to explain you in a very simple manner, that it's a classification problem. If you have to learn in simple way, this is a logistic regression is a classification problem, and linear regression is a regression method to use it. And how to convert linear to logistic? We just use a sigmoid function. So when we use sigmoid function, so it directly convert linear regression to logistic regression. So the curves look like this, and for linear regression it's straight, it's a linear curve. It's like y equals to mx plus c. Let's do. So this is the one thing I usually do. If you want to do, just you can do it, because it's like if I convert into my report format, I usually don't want to show my code to anyone, so I can comment it out code, and I can toggle on and off the raw code whatever I written. Import all the libraries like NumPy, Pandas, Matplotlib, Seaborn. So what are the important libraries you want to import? Just import it. And the main library we're gonna use here is this linear regression. So from sklearn.linear model we imported linear regression, and from sklearn.model selection we import train test split. So that's all. So we have a CSV called salary data. We're gonna use it. So how it look like? So we have something called like years of experience and the salary. So based on year of experience, we're gonna predict what will the salary. So we have only one dependent, one independent variable here. So as I have explained you this graph, like what does it mean. So first thing, let's check the graph size and everything. And the first thing, a good practice here you can do here is, you can, whenever you read this data set, just try to read it the shape also, because mostly people don't look at the shape, but that will be a good practice here. So if you look, okay, I'm sorry, there should not be bracket. So you can see we have 30 data points here. So we can go here and we can see there is no null value, so no need to do any data cleaning and stuff. What we do is, there is like two different methods. There is a ILOC method, then on which you can use x and y variable. So this will be our, as I have said you, let me go back here in my data frame. So this is year of experience and this is salary. So based on year of experience, we're gonna predict what will be the salary. So this is a dependent variable and this is an independent variable. Okay, so basically what we do is, we will use this column to train our model. As a, we'll split this thing as a, this will become x and this will become y, because we have to predict this y variable salary. So we are doing the same here. We are dropping this salary column on the x is equals to 1 means column, and x is equals to 0 is called row. You can use that ILOC functions also here. So it's your wish what you use, and we are using this salary column and putting into this y variable. So we are ready with x and y. And if you are wondering what I'm like pressing to run this key, is like shift and then enter, like press shift and next enter, it will run. So we are checking like what are the shapes of the training and testing data. It's like 30, till now we have not done like splitting part. We are just checking like what is the value, shape of x and shape of y. So it's like 30, like all the salary column, and this is the year of experience that they, those have. That's now let's do this train and test split. So while on the first start of the notebook I have showed you, we have imported model selection, import train test split. We're gonna use this train test split here, and we use train test split x and y. Test size will keep as 1/4, it's like 25% will keep as testing and all other as training. And like I will give you one advice, that always put a random state. So that random state means like whenever you run a code, set of code with some set of variable like x train and y train, so it doesn't change. So whenever you run this model without a random state, you will get different kind of accuracy and precision every time. So in here, better try to give some particular random state, assign it to something you want, like 1 2 3 5, anything you want. We are like using x train, x text, y train, y test. So now our variables are ready. We use this linear regression, we create an object called reg, fit this x train and y train, and then we do the prediction, like we do a prediction of test. So we are passing this x test, because x test is our like the variable we have to test it. We are just passing this regression, this object of this linear regression, we are predicting it, and then we are keeping it in a variable called y test spread. And the y train spread, we can again like use this predict x train again. So it doesn't make sense you do it or not do it, just this part is important, because we are predicting the test data. It's like you have read all the thing for your exam and now you are going to give exam. So x text is like question paper to you, and this y test spread is the result for your question paper. Let me run this. And in the correction problem, we don't have something called like this accuracy, precision, recall. It's all in classification type problem. So in regression we have something called score. So we use that score method to quantify that what's the percent we are getting. It's like 97% accurate our model here is. So we just wanted to visualize it, how it looks like for the training set, because as we are passing the variable here, we just wanted to see how this variable looks like. So we just using x train and y train on the scatter plot, and we are plotting, we are giving year of experience, salary, and we are plotting a straight line by using this x train, because this is for training data set that we have used. So if I have to run this, it look like this. So because this is a training data set and this is the line, like it's very good line only, it is passing most of the time. Then you have to see here a guy with 4 years of experience, you have to plot in this line, and it will go like this. So it's like more than 60,000 rupees, but a guy here is almost getting here, it's like less than 60,000. Model has predicted that they can get more than 60,000, but originally they are getting less than 60,000. So maybe it's a profit for company, not for that guy. And we can't decide like salary by using a simple model, right? So it's a tough call here also. And if we have to take the test part, because this is the important part we have to check, we can see like 1 point, 2, 3, 4. This 4 point are like 4 points are very consistent passing through the straight line, and most of them like are lying below. So it's a kind of good model itself. So I won't say we do have a bad result here. It's a sort of good result. So yeah, that's all we had for this video. So in the upcoming video we will talk more about this multiple linear regression. So stay tuned. So thank you and have a nice day. Bye.